Great to see you here. A new video offered to you by the Custer Academy. My name is Luc de Custer, and in this video we're going to talk about percentiles, quartiles, the range, and the interquartile range of data from samples or populations. Now we're going to have a look at the measures of variation, and in these measures of variation we have the range, the interquartile range, and the other elements we will be looking at in other videos. So let's have a look at what are the percentiles. Well, when we look at percentiles, we look at percentages. There is the word percentages. We're going to look at a number of percentage of the total sample or the distribution or the population. We're going to use them to describe a position in the distribution. And when we look at the p percentile, whatever p will be, whatever integer we select here, positive integer, is basically the value that divides the data into two parts. We have a lower segment which contains at least p%, and the higher part which is 1 minus p% of the data. And when we look at the 50th percentile, 15%, this is basically the median, because it means that we have 50% to the left and 50% to the right, and that's exactly the definition of the median. Some formula and some examples. When we look at the percentile, we look at p, which is the desired percentile. We have n the number of values in the data set, and we say that the numbers or the point where we are going to divide the population or the sample is given by I, and it's equal to p divided by 100 times n. So basically what we're going to look at is, in case the number I is an integer, we have the p percentile, and that's basically it. In the case I is not an integer, we round it up to the next integer value, and this is then the location of the p percentile. Now when we look at some examples here, when we see here a population of 500 data, like the population we had before when we were looking at the measurement of the speed of those 500 cars, when we use the 10th percentile, so we have 10 divided by 100 times n is 500, so 0.1 times 500 is 50, 25th percentile is 125, the 30th percentile is 150, 30 divided by 100 times 500, the 85th percentile is 425, and when we look at the 50th percentile, we have there 250, which is in fact the median. Now, when we look at a different population, we have here a population of 350 data, and the 10th percentile we find it's equal to 35, which is an integer, so that's okay. When we look at the 25th percentile, we find that the value I is equal to 87.5, so we go to the next integer, which is in this case 88. When we look at the 85th percentile, we see that the value is 279.5, and we go to the next point, which is 280. So here we can define whatever percentiles we want, and we can find what is the value which shows the position of that percentile. Elements where we are going to look at special percentiles, and we look at quartiles. Quartiles are a special application of percentiles where we look at the values that are in fact dividing the set of data in 4 equal sized groups. We have 25, 50, 75, and 100. So basically we have the first quartile is equal to the 25th percentile, the second quartile is the 50th percentile or the median, the third quartile is the 75th percentile, and the fourth quartile is the 100th percentile. So basically we have here quartiles as a special case of the percentiles. Example, the formula is basically the same, but now the values of P can be 0, 25, 50, 75, and 100, and the same rules apply. So let's have a look for our population of 500 data. So the first quartile is 25% of 500, is 125. The second quartile is 250. The third quartile is 375. The fourth quartile is 500. And when we do the same on a population or a sample of 350 data, we find the first quartile to be equal to 88. The second quartile to 175, the third quartile to 262.5, which we change into 263, and the fourth quartile, which is 350. And it's very important here to write down somewhere the population, for the population of 500 data, the first and the third quartile, and for the population of 350 data, the same. We're going to use them in one of the next videos to define another concept related to quartiles and percentile. Another element which is very important when we look at data, when we look at distribution, is the range of a population or a sample. And when we look at them, the range is basically the difference between the maximum and the minimum values of the numbers in the sample or the population. So it's max minus min, and typically the range is written or shown as the capital letter R indicating range. And we will use that in other applications. It's a concept, it's very easy to measure to give an idea how far does the distribution spread around the average value. That's a very important element that we define here. We don't do any calculations. Basically, it's quite easy to do the calculations here when we have the values. Now, we just find in the sample the lowest value and the highest value, and we take the difference. Looking at percentiles and quartiles is what we call the interquartile range. Now, the interquartile range is a measure of variation that is determined by computing the difference between the first and the third quartile. That's why I said, remember the values of the first and the third quartiles from the exercise in one of the previous slides. So the interquartile range is equal to the third quartile minus the first quartile. And when we look at our population of 500 data, the first quartile was 125, the third quartile was 375, which makes the interquartile range equal to 375 minus 125, which is basically 250. The next element, when we look at the population or the sample of 350 data, we know that the first quartile was equal to 88, the third quartile was 263, and the interquartile range in this case is 263 minus 88, which is 175. So basically we looked at these different elements, the percentiles, the quartiles, the range, the interquartile range, as measures already of variation. How does the distribution or do the data are spread around the central value? It's very important to understand this when we are looking at distributions. The farther away that those, let's say, data are away from the central position, from the average, it shows that there is a lot of variability, and it may lead to specific conclusions when we are evaluating the data, but we will talk about that later. So that was it for this video. Don't forget to click the subscribe button, click the bell button, so every time we have a new video, YouTube will inform you about it. I thank you very much, and I'm looking forward to seeing you in our next video. Bye-bye.